Good morning, and welcome to the Build Reactive Apps with Flutter session. My name is Matt Sullivan.
And my name is Filip Hráček, and we're both developer advocates on the Flutter team.
So let's kick off with looking at how to build reactive apps in Flutter. Flutter lets you build beautiful apps. It gives you the ability to create fluid and customized, sophisticated UIs. There's a few examples up here just to show you the different range and types of apps that you can build with Flutter. At the heart of Flutter's UI is a powerful reactive model. I'm going to give you the 30-second summary of how it works, and then we're going to deep dive into things. Firstly, in Flutter, all UI components are widgets. As you can see here, we have a widget that's a button. Secondly, you take these widgets and you compose them together to create complex UIs. So we're going to refer repeatedly to what we call the widget tree, and that's literally how we're building these together. Thirdly, and importantly, Flutter manages the relationship between state and UI, and it only rebuilds those widgets when their state changes. And it relieves you of having to do that task. So for example, here, when we call setState on the greeting widget, it's going to automatically redraw itself. And that's great and wonderful, but building complex apps is never easy. Apps typically have thousands of UI components, but more importantly, they have very complicated and potentially sophisticated state that's reacting with those UI components asynchronously at various different times in your app. The good news is that Flutter provides you with all the tools necessary, not only to build UI, but also to handle complex data flow and state in your app that fits in elegantly well with Flutter's reactive model for building UIs. Now, Flutter's UI patterns are well known and well documented. You can check them out on flutter.io. But Flutter's reactive strategies for handling state, not so well known. So we're going to focus the talk on how to do that. So we're going to take you on a journey. Firstly, we're going to look at the foundations of Flutter and state to show you the basis of how things work. What we're going to do then is we're going to explore how state and the widget tree can be married together. And thirdly, we're going to look at how you can use Flutter streams to elegantly manage state in your app. Now, at each of these, we're going to do some live coding. And clearly, nothing's not going to wrong. But we're going to do some live coding. And these examples will be relatively simple. But we want you to keep in mind how these can be scaled out to more complex state and larger apps. And importantly, the examples you'll see here have been derived from production apps built with Flutter, both by Google and by other parties. So let's dive in and look at managing state in the simplest app we can think of, which is the incrementer app, which is what you get out of the box when you do Flutter Create. Flutter's reactive model is straightforward for UI and state, but it's a little different to how things are handled with Android and iOS. So we're going to dive in by looking at this app, and we're going to look at a common pitfall that typically catches people out when they initially start thinking about reactive systems in general. Philip.
All right. So this is a very exciting moment for me because I'm going to break an app on stage at I/O. Which, if you think about it, that's exactly the opposite of what you normally want to do on stage. But this is in the name of learning and science, so it's OK. So if you're not familiar with this app is very exciting. It shows you a number, and it lets you increment that number. The important parts are there's the counter variable, there's the build method that creates the UI. Here's the widget, which actually shows that number 4 right now. And here's the floating action button, which is this guy over here, which lets you change that variable. Now, imagine that this was a much bigger app, and we wanted to put a little more structure to it. And we would do that often by extracting parts of the build method into its own widget, right? So I'm going to do just that. I'm going to take this out, create a new widget called incrementer, and I'm just going to paste the code over here, right? So we're not done. As you can see, there's red squiggly lines over there, which means we have a problem. And the problem is that we cannot actually access the counter variable from here, because we're in this class, while the counter variable is in this class. Right? There are many ways how to solve this problem, but I have something very special in mind. I'm just going to make the variable global, because I can.
So there you have it, folks. To handle state in Flutter, you make everything global. And your app is good, yeah? Is that what we're telling people?
No,
Really?
actually, we're we're trying to make the point here. We're trying to break this app, so please don't make your variables global. And we're going to fix this in 2 minutes. But stay with us. So we fixed the squiggly lines. So let's see if this app actually works now. It doesn't. Now, why is that? We can add a thing here to see if the counter variable is actually changed. And we see that it is. It is now at 12. But the user doesn't see it. Why is that? Well, the reason is that we're calling setState in the wrong widget. We're breaking the contract of setState, which is that you call setState when you are changing the state of the widget. We're not changing the state of the floating action button here. We're changing the state of the widget above it, right? And that way, Flutter doesn't know. Flutter tries to rebuild that floating action button, but that doesn't do anything with our text over here. So I'm going to fix it now.
So what we need to do is we need to move setState into the appropriate widget where we want to show the change or the mutation of the state. So Philip's going to move it back into the homepage widget. And thankfully, we're no longer have any more global state. Wonderful. So, and what we're going to do then is what we need to do is we need to be able to pass down a reference to that function so it can be called by its child widget. So we're basically going to update the incrementer widget. We're going to pass through the function through the constructor. And then what this is basically giving is the classic callback method of being able to call the function in the parent widget. And that should probably just work.
And it works. Awesome.
Perfect.
All right, back to slides, please. All right, so that was great, and it was pretty easy to fix. But you can imagine that if you have a much larger app with a lot more widgets, this could be a problem. Let's imagine that you have you need state over here, and you have state somewhere over here. And now what you need to do is, if you follow that pattern that I just showed you, you need to pass down the state down the widget tree. And that means that all the widgets that are in that path need to know about this state, even though they don't really care. And that breaks reuse. It breaks separation of concerns. And it also potentially makes the app rebuild a much larger portion of the state or of the UI that you would want. You only want the leaf nodes to be rebuilt. So I've hopefully highlighted two problems here, or two challenges. First, how do I access state that doesn't necessarily live in the widget where I need it? And second, how do I notify other widgets that they should rebuild? I'm going to, again, I'm going to score this pattern that I just showed you with a thumbs down on both accounts, because while it is easy in a simple app, in a big app, it gets more complicated. And I think we have a better option here.
OK, so let's look at how we can handle state and the concept of passing state up and down the widget tree without having to expose it to all the widgets in between that don't need to use it. So Flutter has, out of the box, what is called an inherited widget. And what an inherited widget does is it holds state, and it allows you to propagate that state efficiently down the widget tree, and it will rebuild that widget tree when that state is mutated or that state changes. So that sounds promising. That might help us solve this. What is this going to look like? Well, basically, you have an inherited widget. We've put it in here. And as opposed to having to pass down references to it, we can use the build context in any of the build methods to get an access to the instance of that state and use it directly within our widgets themselves. So what does that look like in code? So here I have my really cleverly named myInheritedWidget, which extends inheritedWidget. And in here, you can see that I have placed some state. Perfect. How do I access that? Well, I can access it by firstly placing my inherited widget into my tree, giving it some state, and then building the widget tree beneath it. And then after that, I can access it by simply using the build context to get a reference to that widget, and then I can access the state. So that sounds promising. That's good. Well, sure. Now I can access state anywhere in the tree and keep the rest of my code dry. My tree at a coarse grain level does rebuild when my state changes, so that's OK. But as you noticed, my state was final. That's not very helpful if you actually want to mutate your state. Now, it's not hard to layer in mutation with inherited widget. It's a bit of boilerplate. So what we're going to do is we're going to look at a library called scope model. And scope model is an external package. It's built on top of inherited widget. And importantly, it gives us the access. It gives us a more fine-grained way of rebuilding parts of our tree. And it allows us to mutate state as well. So looking at code real quick, scope model equates to my inherited widget. And we have what's called a descendant, which gives us access to the state. This is great. I'm showing all this stuff on slides. I want to show it in real code to show you it working. But I don't want to show it to you in the incrementer app because that's pretty simple. So Philip and I knocked up a shopping cart example. And what that has is it has 3 areas where you need to handle your state. We've got a cart page, which shows the list of items. We have a cart button, which shows the number of items in the cart. And we have a grid of products where each product is tappable and should add something to the cart. So let's jump over to my laptop. And take a look at this. Perfect. OK. So here we have the app, which is already running. You can see I have a grid of products. And at the moment, it's just showing a snack bar at the bottom. We have my cart button, which is hard-coded to show 0. And we have a cart page, which currently is showing empty. There is no state anywhere in here at the moment. These are all stateless widgets. This does nothing except look pretty, if you consider this to be pretty. We're not designers, but there you go. What do we need to do? First, we need to define our model. So I have created cart model. It extends model, and what it does is it simply has a cart object, which is holding our state. We have 3 different ways of interacting with this. We got a getter to pull down the list of cart items. We have item count, which gives us the number of items in the cart. And strangely enough, we have an add method or function, which allows us to place a product in the cart. Now, notice here, when I mutate or change my state, I'm explicitly calling notify listeners. And the way scope model works is that whenever you have a descendant widget, they are observing your state. They are listening for changes. And when our state changes, we simply call notify listeners, and all of those descendant widgets will be notified that state has changed, and they will rebuild. So the whole tree is not being rebuilt. Only those widgets that are listening to it and the things below them will be rebuilt. Perfect. So let's see how I can use that model to inject some state to my app. So what I'm going to do is I'm simply going to place my state at the topmost level of my app for ease to begin with. So what I'm going to do is I am going to wrap this in a new widget, and it is going to be a scope model. And as we can see here, scope model takes a model and a child. So we can keep the subtree as a child, and I can place a model. And I'm going to create a new instance of cart model. OK, so now I have state existing at the top of my tree. Great. I need to access that state, so how do I do it? So let's go down and take a look at our button. And here's our button. And you can see at the moment hard-coded to show 0. So what I'm going to do is I'm going to follow the same type of pattern. I'm going to wrap this in a new widget. And this time, I'm going to use a descendant widget. I'm going to type it so it knows what type of model to look for. And this doesn't take a child. It takes a builder, which will provide me with the model. So I'm going to change my child to builder. And this is a function. I need the build context because that's how inherited widget finds or gets a reference to it. We have an optional child widget I'm going to use, and we're going to have a model. Great. So what can I do now? I should be able to simply do model.item count. Perfect. We got to do one more thing to get this to work. We got to add some products. I'm going to do this super quick. Here we have our grid. Here we have our individual products. And again, I'm going to follow the same pattern. I'm going to wrap this in a descendant widget. I'm going to type it. I'm going to do that properly. And then again, I'm going to change this to a builder. Make this a function. Take my context and my model. And so now what we can do in here is we've got all of this snack bar code, which I can get rid of. And I should be able to do model.add. And we have a product and OK. So this is all hot reloaded. I've placed state in there. I don't have to restart my app. And we'll see if this works. There we go. So we've gone from stateless to stateful. I haven't changed the structure of my app. All I've done is I've layered in a few extra widgets. And with the way that this app is built, this has worked really nicely.
This is nice, Matt. But didn't you say that whenever you call notify listeners, you will rebuild the things below the descendants? Which means that we're now rebuilding the product squares every time you click.
So as we pointed out before, notify listeners notifies all the descendants. So we're rebuilding this button. But we're also rebuilding all of these products, which is bad, not great. So why don't we fix that real quick? Because scope model descendant has a rebuild unchanged flag. And I can set that to false. And so you shouldn't see any difference here. But what's happening now is these product squares are not being rebuilt. I already implemented descendant for the cart page because you don't need to see me type this a third time. But it's exactly the same model there. Perfect. So let's jump back to the slides. Thank you. Great. So what does that get us? Accessing state. We can access state arbitrarily down the tree without having to mess with our intermediate widgets. Perfect. We have a reasonably elegant means of notifying our widgets now by our descendants observing for state change, and then rebuilding when that state changes. Now, minimal rebuild, I'm going to give a thumbs down. And that's because I had to, A, be reminded by Philip, because I constantly forgot every time we rehearsed this to do this, that we had to not rebuild that part. There's a cognitive load at that point for the developers. You need to work out, should this rebuild, shouldn't this rebuild, what's going to happen? And when you evolve your app, you have this additional level of needing to worry about this. So I don't think this is great, and I think we probably need to come up with a better solution to that. Funnily enough, we're now going to look at Flutter support for streams, how streams can be built to fit in with Flutter's UI reactive model, and how they can solve this very problem.
Thank you. So let's talk about streams. If you're more familiar with the term observables, they are very closely related. And for the purposes of our talk, they are basically interchangeable. So if you think about application development, streams are everywhere. Every user input is a stream of asynchronous events. Every interaction with the underlying system is a stream of asynchronous events. Every interaction, obviously, with the outside world through network is a stream of asynchronous events. And crucially, if you think about it, all your updates to the UI is a stream of asynchronous events. So people who are familiar with ReactiveX and reactive programming in general probably know where I'm going with this. But suffice to say, it makes sense to think about UI programming as managing stream of asynchronous events. The good news is Dart has a really good support for streams. It has had that for a long time. Dart streams have all the usual bells and whistles that you would expect, like stream transforming, mapping, folding, and so on. And Dart even has language-level support for streams, like asynchronous generators, the yield keyword, or await for. So we have this concept of streams in Dart, and it is used throughout the Dart ecosystem. And then we have this, this concept of reactive extensions and reactive programming. On top of that, there is a package called RxDart, which builds the reactive extensions on top of the inherent streams in Dart. So this is really great. How that fits into Flutter? Well, Flutter has this widget called Stream Builder, which is exactly what you'd think it is. It is a widget that takes a stream as an input and a builder method that will rebuild every time there's a new value on the stream. So anytime you have a stream, like when you're subscribing to a Firebase database, you can just use Stream Builder to rebuild your UI. So that is already pretty cool. But wouldn't it be even more awesome if we had some kind of architectural pattern to build our apps? So imagine that you have a big app, and it has some widgets that take user input. So therefore, they have streams of asynchronous events coming from the user. And then you have other widgets that can be anywhere else in the widget tree that try to update whenever there is a state change. Now, you cannot just simply link those two together. You need something in between, and we'll call that business logic for now. So you need to stream the events from the widgets that have buttons and inputs to the business logic. Then their magic happens, and the business logic publishes streams of data changes to widgets that are interested in it. And these can then rebuild. Crucially, you're publishing separate streams. So the other widget could be interested in a completely different aspect of your data, and it will just subscribe to that stream. So it won't rebuild anytime there's any change to your model. It will only rebuild when there's change to that specific aspect of the model. So let's have a closer look. We have streams as inputs, streams as outputs. How would that look like in Dart? Well, we would have an object that has sinks of events as inputs. Sinks is the equivalent of, it is the input of a stream. You put things into it, and then you can listen to it on the other end. And then there's a stream of data as output, So pretty simple. Now, in our example with a shopping app, the simplest possible cart would be have a sink of product called addition, to which you would just shove your products into. And then it would have a stream of integers called item count, which would update every time the item count changes. So internally at Google, we call these business logic components. So that is block for short. Let's switch to the computer, and I'm going to implement it real quick. So this would be my computer. Yes, I have the same app. It doesn't change. It doesn't currently work, and we'll need to implement this pattern. So I already have a card provider that uses inherited widget, so that I can access this object from anywhere in my tree. And as you can see, I'm creating this object here, and then I'm accessing it in different parts of my app, but I'm not doing anything with it yet. Also, if you look at the object now, or the component now, it is pretty empty. It only has the underlying model. So what I'm going to do is I'm going to first implement the sink of products, the input, the streaming input. I'm going to very quickly code it up, and then I'm going to tell you what it does. So it's going to be a sink of product called addition. This is that input stream that you can access externally. And then this is backed by a stream controller called addition controller, which is stream controller is just a basic class in the stream library in Dart, the core library. So, and that helps us listen to the stream of things that are coming from outside. Now, how would you use it in your app? You would just go to the product squares, and wherever you are trying to add the streams of events, you would just say card block, the sync, and then we want to add to the sync. And in this case, we want to add the products. Right? Coming back, we want to also code the output, which is a stream of item count. So again, let me just quickly do that. Item count is a stream of int. And it is backed by something something that you might know, behavior subject. Behavior subject is coming from reactive X, and it is a different kind of stream controller that has memory of its latest value. So whenever you listen to it, it will immediately give you the latest value. This is in contrast to normal stream controllers or streams, where when you listen to it, you will have to wait until the value changes. That could be sometime in the future. In our case, we want to have always the latest value the moment that we listen to a stream. Now, how would we use that? Well, now we get to use the stream builder class. So we have the card button here. We want it to listen to changes to the item count. So I'm going to wrap it with a stream builder of integers. It's going to listen to the item count stream. The initial data is going to be 0. And then in here, I can just access the snapshot of the data, which will always be the latest value of the item count. Right? So if we have this. Now, all we need to do is to merge the streams together. So that's what I'm going to do just now.
So this is where Philip will make the magic happen behind the scenes, because we've got a bunch of products coming inbound. And what we need to do is we need to listen for changes on that, because we're not capturing it at the moment. We need to add those products to the cart itself. So what Philip is doing now, he's getting access to the stream, he's listening to it, and then the product will be the event coming in. And all we need to do at this point then is add that product to the cart. Great. So now we have state managed. The other thing we need to do is make sure that item count is always updated when products are added. And all we need to do there is do what we did in the opposite direction, is to add the item count to the item count stream, and we're done?
Yep, we're done. All right,
Okay.
back to the slides, please. So as you could see, we were able to implement this business logic component pretty quickly. It is a little more complicated, but it gives you a lot of cool stuff. First of all, it is really just streams in, streams out. Whatever happens in the component, you don't care about as a Flutter UI. Then we could add more things to this block, right? So we could add a stream of total cost. So whenever the cost of the card changes, you probably want to update your user to give it that. And then you have a stream of list of card items, which is the items that you want to always update whenever you add something to the card or remove from it. Right? So that is cool. And again, these are different aspects of our model that we want to show. Now, I have a problem with one part of this, and that is this part. We're streaming the total cost as integers, which makes sense internally in the component. It is a numerical value after all. But what it leads to is code in your views like this. You have to somehow convert or format the numerical value to some kind of string, right? Which is, if you think about it, this is business logic. This shouldn't be in views. So you can go back to your card block, and you can just change this to a stream of string that is already formatted. So whenever you want to show your total cost, you just stream the formatted one. And so you just reuse that same business logic that is inside the component now. That gives you another very cool thing. And that is that if you add a new sync or new input to the model, to the component, for example, sync of locale. So users now can change anywhere in your app. They can change from US shop to EU shop. Now you can pipe this change as a stream to the total cost. And so internally in the block, you will update the total cost string, even though maybe the numerical value is still the same. And that means that anywhere in the app that the user changes this, you don't need to think about it as a developer. It will always update anywhere else the total cost. This would be a real pain to implement any other way. So we have this nice flow of data and events. We have widgets that are only listening to what they need to know. And we're using good old stream builders to make that work.
So let's take a look at what we have now. Accessing state, in Philip's example, was solved by using the inherited widget pattern to pass access to the block down the tree. We now have very fine updating on change because we have different aspects of our data being represented by different streams, and those widgets subscribing to those streams will only rebuild when those aspects of data changes. And finally, we now have the converse. We have mutating state by pumping data or requests to mutate state into our business logic, where we're observing for change, and then we can update it there. So there's this nice pattern of pushing data in via streams and then updating via streams, which we think is very elegant. So this is great, but you all have options. Set state works fine if you have a very shallow tree and your app is fairly simple. Scope model is a fantastic way for a model which is relatively straightforward to be passed up and down and change on a tree of arbitrary depth. For those of you who like the Redux pattern, there is an excellent Redux implementation built by the community, the Redux package for Dart and Flutter Redux for Flutter, which will give you that pattern, and you can use that as well. But if there's one thing that we'd like you to take away from this, it's that Flutter's widgets, in combination with streams, gives you a very reactive way to not only handle your UI, but handle the flow of data through your app and handle the updating of your UI when that data changes. So we highly recommend you go and check out Dart Streams and the RX Dart package as an option for building state in your apps. We'd love to hear from you. Please go to the site and give us some feedback. All of the code you've seen today is in Philip's GitHub account. I did some pull requests, honestly. He didn't write everything. And not only do we show you the code we showed, but we have a Redux implementation and a couple of others there as well for you to check out. I want to give a shout out to the cookbook that us in the community have been working on. There's some wonderful patterns in there, from everything from widget creation to network to JSON. It's a great place to go. And there were 2 other talks that have happened prior to this. Fortunately, we have a time machine called YouTube, so you can go back in time. And if you want to learn about building beautiful UIs or building apps end-to-end, I would recommend you check those out. Those are good talks. And I would like to say thank you for your time.
Thank you.